Okay, there we go. Now I've got it going. We're going to do old school, some long division today. 4.5 minutes since we did that. So, I'm going to zoom this in here. How many times does 23 go into 427? If we think about that, the way we do that is how many times does 23 go into 42? Goes in one time. 1 times 23 gives us 23. And then we subtract. 42 minus 23 gives us 19?
19.
19? Sweet. And then we drop down our 7, right? Mm-hmm. How many times does 23 go into 197? That one's a little harder. 8 times? I'm trusting you on that one. I haven't gone through this one yet. All right, so, and then we have 8 times 23.
184.
Is it 184?
Yeah, 84.
Sweet. Love it. And then again, we subtract, right? So we have 0, 1, and 3, right? Yeah. Cool. As long as we match, we good. So we have an 18 with a remainder of 13. Or we could write this as 18 and 13 23rds. That's how we get our mixed number. We take our remainder and we put it over what we divided by. All right? Because we're going to practice this a lot more Algebra 2-y, going back to something we did, I want to say it was December, where we were doing our polynomial long division. We're going to remember how to do that, because that's going to come up again next week when we start working with switching from the big ones where we simplify down to the ones that we can graph. So what we're going to do is we're going to look at this question here, if my screen will zoom in for us. Oh, it's twitching on it. There we go. I have a problem trail, but not a walking around problem trail, but one you guys are going to work on at your desk, and probably with a partner. But I want to go through one of them together. So this will be question 1. And what we're going to do is we're going to take what's on top. You guys aren't going to need your notes for today, but if you want to write this on, you can. There's space on the cover. Our 4x squared minus 2x plus 6. And we want to divide that by our 2x minus 3. It's been a minute since we did our polynomial long division. We look at our first term of what we're dividing by and our first term of what we're dividing. How many times does 2x go into 4x squared? 2x times. Or you can think of it as 4x squared divided by 2x. Whichever way works for your brain to think about it, do it that way. But we take the first thing we're doing.
Here's what I found.
Not you. So you can also do it as 4x squared divided by 2x, and that gives us 2x. We take our 2x and we multiply it by this whole piece here and put it underneath. So 2x times 2x gives us, ooh, that's not a pen, 4x squared, and 2x times minus 3 gives us minus 6x. And then just like we did on the other one, we subtract these two lines from each other. 4x squared minus 4x squared gives us 0x squared. So that's exactly what we want. If this is not 0, we did it wrong, because that should cancel out. This is where we need to be extra careful, because we have minus 2x minus negative 6. So we wind up with a positive 4x. And then just like we did with the 7 on the bell work, we're going to drop down that plus 6. Questions on the first round of that, because we're not done yet. Then we do the same process, taking our first term here and our first term here, and we're going to divide those. Whoa, that's not a pen again. 4x divided by 2x. Or how many times does 2x go into 4x? What does this simplify down to? 2. It's like the x's cancel out. So we're left with just the 2. We have a positive 2. I'm going to write that up here. I need a different color. There we go. Positive 2. And we do the same process as last time. We're going to come and we're going to multiply it by this whole term and put it under here. 2 times 2x gives us, ooh, I keep forgetting to switch to a pen, 4x. 2 times minus 3 gives us minus 6. And again, we are subtracting here. 4x minus 4x gives us 0 x's, which is great. That's what we want. They should cancel out. And be super careful here because we have positive 6 minus negative 6. So what goes here?
0.
6 minus negative 6? 12. The instinct is to put 0 if you're like, same number. We like it to cancel out. Thank you very much. We have a remainder on this one. So just like we did in the bell work where we put it as a fraction, we're going to take all of our terms and add them together and leave that as a fraction. So our solution here, our fully simplified version of this fraction, I'm going to write it down over here. We have our answer is what's on top, 2x plus 2 plus our remainder, 10, divided by what we divided by, 2x minus 3. So just like when we had our remainder and we wrote it as a fraction here, 18 plus 13/23, we can do the same thing with the polynomials if it'll pull the screen back up. Not at all delayed on my iPad. It's being a jerk. Oh my gosh. Why is it being such a jerk? There, why is it? There we go. I don't know why it's being a jerk. Just being a jerk. Okay, so this is our answer. And what we're going to do today is we're going to do like a problem trail, working through problems just like this, writing them into polynomials with these remainder fractions. This is the part we're focusing on today. Like, this is critical. We are going to be using this part, and therefore this part, Monday, Tuesday, and Wednesday of next week. So we need to remember how to do polynomial long division. We need to remember how to write a remainder as a fraction, okay? So the activity we're doing today, you can do today by yourself. You can. I'm not going to say you must socially interact. It gives you 12 problems to do by yourself. That's a lot. It's a lot. So if you work with a partner, you only have 6 problems to do. I highly recommend a partner. We did just do the first problem. So what you're going to do is you're going to cut these cards out. Question 1 here is that problem up on the board, and it gave us an entirely different answer. Oh, that's because that's not the answer. I'm like, what? So we did this question, and we're going to find our answer on one of these other cards. 2x plus 2 plus 10 over, maybe was it 12? Oh, yeah, 12, because 6 plus 6 is 12, and I wrote 10. I'm good at mathing. I'm like, why is it not matching? 6 plus 6 is 12, which means this is 12. I'm good at mathing. Totally did not even connect that. So that means question 1 is going to lead to question 8. So I want you to ideally find a friend, find a buddy, find a stranger. I don't care. We don't recommend an enemy. But find someone you're willing to work with. You're going to cut these all apart. You can split them up and work on dry erase on the desk. Totally fine. But they should lead to another one on here. Question 1 we just did leads to question 8. So one of you guys start with 8 next. That'll lead to another one. You guys can work them in pieces. I have tape up here so that as you get them cut apart, you can tape them together, like on the back for the color tapes, because I have lots of like washi tape. And we have one tape that has Spencer that has Scotch tape, so you can tape on the front. But so come grab a paper, come grab a tape, and these should make one big loop. It'll loop back to the beginning. So the very last one you do will give you the answer that's on question 1. Okay, I will leave this up on the board. I am here to help. I am happy to help. I would love to help. Okay, but that's what we're working on today. It's pretty chill.